In August of 1923, the largest, heaviest aircraft built up to that time in the United States lumbered into the sky for the first time. Its official designation was XNBL-1, or Experimental Night Bomber Long Range, but most simply refer to it as the Barling Bomber. It was the culmination of years of labour, blown-out budgets, bankrupted manufacturers, and political controversy, all in the name of proving that the heavy bomber was the ultimate weapon of the future. Its existence can be owed, more or less, to two people, William Mitchell, aka Billy Mitchell, and Walter Barling. Mitchell, who by the end of the First World War had commanded all American air units in France, returned to the United States in early 1919. He was convinced that air power would be the dominant military force in any future war, and unlike many of his sanguine colleagues, he doubted the claims that the last conflict had been the so-called war to end all wars. In his quest to prove the future importance of air power, Mitchell found himself at odds with the leadership of the US Navy. He was concerned with the continued building of heavy battleships, believing their high cost was draining funds that could be better served on military aviation, naval or otherwise. In his mind, 1,000 naval bombers could be built for the cost of one battleship, and they would be able to defend a vastly greater area of sea and be redeployed more easily. He urged for the development of naval aviation, believing that aircraft would eclipse the powers of the surface fleet, and emphasized that future strategies for national defense must be made up of land, sea, and air components. His suggestions were met with cool hostility, either because he was an army officer, or because his suggestions diminished the influence of the fleet or regular land army, or because he had already managed to alienate various superiors, something he was known to be rather effective at doing. Frustrated by the lack of progress in military aviation, Mitchell set out to prove that air power could equal, or even eclipse, traditional sea power, and at some point in 1919, this led him to cross paths with Walter Barling. Barling had been one of the designers of the Tarrant Tabor, a large, six-engined, experimental triplane bomber that had been designed to bomb Berlin during the war. However, the war had ended before its completion, and the aircraft had then been destroyed during its maiden flight, courtesy of some ludicrous engine placements. Billy Mitchell had heard of the Tarrant Tabor, and the concept of a heavy bomber greatly intrigued him, and so when Barling emigrated to the United States at the end of 1919, Mitchell approached him with a proposal. He wanted Barling to design a bomber that was capable of sinking a battleship. It would have to be large to carry the required payload, but he believed it could be done. Barling agreed to the proposal, and he immediately began to draw up preliminary design concepts. These concepts were quickly approved by Mitchell, and in May of 1920, the Army Engineering Division drew up a specification based on Barling's preliminary designs. After its approval, manufacturers were sought out to bid for a contract for the construction of Barling's bomber. The specification called for a ground-level top speed of 100 miles an hour, a climb to 7,000 feet in 20 minutes, a service ceiling of 10,000 feet, and a fuel supply large enough to support a 12-hour flight at this service ceiling. And all of this had to be achieved with a bomb load of 5,000 pounds. Bids for a construction contract were received from 3 manufacturers, but the winner was found to have inadequate production facilities, and so the runner-up, Witteman-Lewis, was chosen. The New Jersey-based company received a contract to build 2 experimental triplane bombers at a total cost of $375,000. At Mitchell's insistence, the Air Service named Barling as the chief engineer in charge of the project, with salary and expenses paid by the manufacturer, of course, and full-scale design work began in the second half of 1920. In its design, this new bomber shared some similarities with the ill-fated Tarrant Tabor, but it also showed where Barling had learned from its failure. The fuselage, at least, bore a strong resemblance to that of the Tabor, being a large, imposing, cigar-shaped structure that was approximately 65 feet long. It was constructed as a semi-monocoque, being built in circular sections that were bolted together, and the whole lot was covered with a streamlined shell made from 2-ply spruce planking. The inside of the shell was reinforced by circular bulkheads and spruce longerons, and the outside was then protected by a fabric covering with waterproof paint. Extending rearwards from the main fuselage was a large cone structure that supported the enormous biplane tail arrangement. This had been considerably enlarged compared to Barling's previous design, owing to a strong desire for better pitch and rudder authority, a lack of which certainly contributed to the fate of the Tarrant-Tabor. In terms of describing its overall layout, the fuselage could be subdivided into 4 main sections: the nose, the engineer's cabin, the fuel and bomb bay section, and the tail. The bomber went through several redesigns during its construction, some voluntary, some forced, which we will get to later. But the final design had a crew complement of 7, 2 pilots, a bombardier, a nose gunner, a flight engineer, a navigator, and a radio operator. The nose held the pilots, gunner, and bombardier. The gunner sat in a circular open cockpit that held a flexible mount for a Lewis machine gun. Behind this position, the 2 pilots sat in a semi-open cockpit that had a pair of openings, and below them, separated by a floor, was the station for the bombardier. The bomb sight peered through a V-shaped opening in the nose, and the bombardier was sat directly behind this on a bicycle seat, which for long-distance flights couldn't have been particularly comfortable. Further aft, the engineer's cabin occupied a full-diameter section of the fuselage ahead of the fuel tanks and bomb bay, and this contained the numerous controls for the engines, electrical, and cooling systems. Behind this cabin, and over the front end of the fuel tank, was the cockpit used by the radio operator and navigator. Though there was only 1 dedicated gunner, and in fact some sources claim there was potentially no dedicated gunner at all, the Barling Bomber was bristling with defensive armament that members of the crew could use to ward off enemy attacks. The upper section of the fuselage was protected by 4 machine guns across 2 stations, the nose and another aft of the wings, and the lower fuselage was protected by machine guns mounted in the floor, 2 in the bomber station and 2 mounted individually between the midsection and the tail. The provision of dedicated cabins and stations for the bombardier, engineer, navigator, and radio operator, complete with modern equipment, was a revolutionary concept that was well ahead of its time. Some bomber designs during the war featured elements of this layout, but the Barling Bomber was the first to encompass everything, and this was because its sheer size allowed it. In comparison with the Tarrant-Tabor, the design and layout of the wings is where we see some of the most obvious differences. At first glance, it appeared to be a triplane like its predecessor, but the gap between the upper and lower wings was noticeably smaller, being only 19.5 feet, and the middle wing was of much narrower chord and span. This wing layout has led many to say that the Barling Bomber was not a true triplane, as the middle wing lacked control surfaces and produced less lift due to its reduced size. And while this is technically true, I think the best way to describe the design of the aircraft was to call it a biplane-triplane hybrid. This is because it took advantage of the benefits found in both designs. The use of 3 wings, though one may be smaller, meant that the overall wingspan of the aircraft was smaller compared to one that would be needed for a biplane design of the same scope in terms of weight and performance, etc. At the same time, its overall height was lower compared to traditional biplanes, which were naturally very lofty affairs, as it was now in some ways an oversized biplane with an auxiliary surface stuck in the mainplane gap. And this meant that the aircraft would be more stable on the ground and during takeoff and landing. One thing that was not an improvement was the power plant situation. Between 1917 and 1919, the United States had produced over 20,000 examples of the 27-litre V12 Liberty engine, and after the end of the First World War, they had a considerable surplus. As a result of this surplus, the US government mandated that all new bomber designs must be powered by this engine. Barling's original plan had been to install 4 powerful engines, but as the Liberty engines only produced 420 horsepower, he was once again forced to install 6, like he had done with the design of the Tarrant Tabor. Unlike the Tabor though, all 6 of these engines would be installed between the lower and middle wing. They were housed in 4 nacelles, with the inner pair containing 2 Liberty engines and the outer pair containing just 1. The engines set in the tractor configuration drove 4-blade propellers, and the 2 pushers drove 2-blade propellers. Being water-cooled, each engine was fitted with a side radiator, allowing a total water flow of 74 gallons per minute, and brass expansion tanks were streamlined into the interplane struts over each nacelle. These engines were fed by 4 25-gallon gravity tanks that themselves were fed by a massive 2,000-gallon, or 7,500-litre, main tank in the fuselage. This tank was situated above the bomb bay, being separated by a floor in a similar way to the pilot's and bombardier cabins, and 2 small walkways ran along either side of the tank to allow uninterrupted passage throughout the entire length of the fuselage. The complex construction of the fuselage, along with control equipment, fuel tanks, engines, cooling systems, and wings, all added up to no small amount of weight, and that was before the bomb load was even taken into consideration. During design and construction, the estimated empty weight crept up several times, eventually exceeding 25,000 pounds, or 11.5 tons, which, for 1921, was exceedingly heavy. The original wheels which had been selected for the design, which were surplus British Palmer wheels, were now deemed unsuitable due to the increased weight, and in their place, 10 air service wheels were installed, including a pair on the nose to prevent noseovers on taxi and takeoff. As construction of the bomber progressed, Billy Mitchell continued with his campaign to prove that battleships could be sunk by aerial bombing, and thus tick off most of the naval staff in the process. During 1921, the Secretary of War and the Secretary of the Navy agreed to a series of joint Army-Navy exercises, known as Project B. Over the summer, surplus American or captured German ships would be used as targets to test the effectiveness of aerial bombing on different classes of naval vessels. Project B probably deserves its own video, and this is for 2 reasons. 1, the project eventually demonstrated the capacity for aircraft to sink capital ships using explosive weapons, and 2, it very publicly displayed the political turmoil within the military services. From the very outset, the Navy and Army Air Service were at cross purposes regarding the tests. The Navy made every attempt possible to improve the survivability of the target ships, which included restrictions on where and when the ships could be bombed, how frequently they can be bombed, and they also delayed several bombing runs on numerous pretexts, the end result being that the bombers ran low on fuel before they could complete all of their bombing runs. Things came to somewhat of a head with the sinking of the ex-German battleship Ostfriesland, which included so many interruptions that the Navy claimed it sank due to gradual, uncontrolled flooding, rather than direct bomb damage. The Navy's false confidence quickly turned into anger and embarrassment when Mitchell's bombers, unimpeded this time, went on to sink the pre-dreadnought battleship Alabama. The aftermath of Project B is best described as politically chaotic, and I won't go into detail about it now, but it did prove that battleships could be sunk by aircraft, and Mitchell had high hopes for the heavy bomber that was being built by Barling's team. Though Mitchell had enjoyed some personal success with Project B, the heavy bomber project had run into some serious problems. Numerous design changes had caused delays, and the logistics surrounding the aircraft's construction were causing costs to skyrocket. The factory in New Jersey was not large enough to facilitate the full assembly of the aircraft, and so the components had to be shipped by rail to Wright Field for assembly in a special hangar. This meant that if any of the key parts didn't fit together properly, they either had to be modified on the spot, or sent 400 miles back to the factory, both scenarios costing time and, more importantly, money. By the time the bomber was completed in 1923, the costs had risen from the initial estimate of $375,000 for 2 bombers to over $525,000 for just the first. Witteman-Lewis had to absorb the additional costs, and the company eventually went bankrupt in 1924. But finally, after years of design work, cost overruns, and a 94-day assembly process in the hangar, the Barling Bomber was at least completed and delivered, and so preparations began for its first flight. Many doubted its ability to fly, especially as it had been completed with a heavier weight than expected due to its design complexity. The Liberty engines were already considered underpowered for the task, and in its finished state they were estimated to barely produce enough power to propel its bulk into the air. One authority on the project was quoted as saying that if 2 engines had to be shut down, the plane had to land as quickly as possible, which was probably a nicer way of saying that it would fall out of the sky like a tranquilized pigeon. Initially, test hops were made before the more ambitious full ascension, and these highlighted a problem with insufficient cooling. This required the installation of at least 2 additional radiators, at the cost of even more weight being added to the airframe. But after this was done, the aircraft was finally deemed ready to fly. And so, despite some comments that the bomber would roll all the way to Dayton before it actually took off, the Barling Bomber finally lumbered into the sky on the 22nd of August 1923. The first flight lasted approximately 28 minutes, and reached an altitude of 2,000 feet. This was done well below the maximum expected loaded weight, and the aircraft only carried 4 people and approximately 350 gallons of fuel. Among those 4 people, though, was Walter Barling himself, whose monumental relief could only be imagined when his ambitious plane took to the sky and then also decided to stay there. Following a surprisingly easy and gentle landing, the pilot and crew report for the bomber was mixed, but leaning towards favourable. The aircraft was found to be stable in level flight and in a climb, and it was able to safely maintain a hands-off climb with the horizontal stabilizers trimmed at between 2 to 3 degrees. There were still issues found with the cooling though, especially during the climb, and the aircraft did suffer from vibrations at higher airspeeds above 90 miles an hour. The problem of vibrations was solved by reversing the propeller configuration. The tractor propellers were now 2-bladed, and the pushers were 4-bladed. Cooling was improved with even more modifications to the radiator system, though it's unclear if even more radiators were added, or if the improvements were limited to those that were already installed. Following these modifications, and after a second flight to confirm they had at least improved upon things, Billy Mitchell supported the idea of the bomber being used for a series of public record-setting flights. Over the course of October 1923, the aircraft set 4 records for both carrying capacity and endurance, which seemed to prove that the concept of a strategic heavy bomber was indeed attainable. Everywhere the Barling Bomber went, it attracted crowds of people, nothing of this size having flown in the United States, and the bomber attended several air shows and meetings across the Midwest during 1923 and 1924. During one of these flights, the aircraft set records for altitude, payload, and endurance when it carried a payload of 4 tons for 1 hour and 47 minutes, reaching a maximum altitude of 4,470 feet. Though it was setting records, the bomber could not carry its intended payload of 5,000 pounds anywhere near its intended service ceiling of 10,000 feet. It just didn't have the power to do so. The engines were inadequate to the point of being dangerous, and this was further hampered by both the weight and the drag produced by Barling's complex airframe. These problems were painfully highlighted when the bomber was slated to appear at a public air show in Washington, D.C. It took off from Ohio to make the journey in an attempt to display its cross-country capabilities, but it lacked the power to climb over the Appalachian Mountains, and it was forced to turn back. This became a huge public embarrassment for the project, and Mitchell personally, as he had been championing the project and the capacity for heavy bombers. This led to some of his opponents, and members of the press, to label it as Mitchell's Folly. Its last flight took place in 1925, the same year as Billy Mitchell's court-martial, which was the culmination of years of bad blood, friction with the Navy, and one too many of Mitchell's criticisms of the military leadership. Its association with such a controversial figure, and the fact that a $700,000 hangar had to be built to protect it from the rain, ensured that the Barling Bomber would never fly again, and it was eventually dismantled and put into storage in a depot at Fairfield. Later on, it would be burned by Major Henry Hap Arnold, himself an aviation pioneer, and later the only officer who would hold 5-star rank across 2 different US military services. He had testified in support of Mitchell at his court-martial, and the bomber to him was a bitter reminder of both his and Mitchell's failings, and the general apathy held towards aviation in the early 1920s. He submitted a request to salvage parts from the Barling Bomber, and to then burn the rest. But this was denied due to lingering congressional interest in the old airframe. He then submitted an identical request, but changed the name to the official XNBL-1, removing any mention of the name Barling, and this time it was approved, and the aircraft burned one night at Fairfield at some point in 1930. Opponents of the project would label it as a failure, but in reality, something so advanced and experimental for its time cannot simply be assessed as such. Though it had not achieved its intended goals, the Barling Bomber was a bold step in the right direction for the development of large multi-engine aircraft, specifically bombers. Several problems in airframe construction were solved with its development, and it served as a far more useful testbed than any scale model in a wind tunnel, something Major Arnold himself would later admit in his memoirs. For the short term, though, the apparent failure of the Barling Bomber meant that something of this scale would not be attempted for another decade. Not until the development of the Boeing XB-15, but in those 10 years, many advancements had still been made. While the Barling Bomber struggled to carry 2.5 tons over a few hundred miles, the XB-15 could carry 5 tons over 3,500 miles. But that's a story for another day. As always, thank you all very much for watching, and a special thank you, of course, to the patrons, with a special shout out to Kevin, Deliardo, Bain, FB, Christopher R, Tronathon, Eric Heineman, and John Austin Jr. for their support as Wing Commander tier patrons. Thank you all so much, and I'll catch you all next time.